Hello there. So we are going to be doing a kind of Strange Young Man stream today. Actually, I probably should have set my microphone up a little bit better than I have for this. I was not thinking about the fact that we are streaming at a different table even. So this here is my work table. It has been moved so that I can stream on it. And yes, this will be a Strange Young Man stream, kind of. I mean, obviously to start with, we are not doing Strange Young Man stuff. We are doing Flop here, my kind of multi-bot flipper, effectively. And yeah, it needs to come apart because Strange Young Man needs parts out of this robot, so we need to get this going. Hi Mark in chat, good to see you. Also, if you see me looking all the way over here, I am looking at you in chat because yes, my computer is over there and all the cameras and stuff are over here. It just makes it easier for me to stream. Actually, I might just quickly fix this microphone because I feel like it's going to bug me just a little bit. So I'm going to go quiet for half a second because otherwise you'll hear lots and lots of bumping noises. So... Okay, that should be better. Hopefully that sorts that whole problem out. And we can start looking at Flop here. Also, I will say, yes, we will get to Strange Young Man. There are some problems with Strange Young Man right now. So this stream was intended to be a full build of Strange Young Man, getting that finally ready for the weekend, because there is a competition in Brisbane next weekend, which I will be attending. However, things have gone wrong, but we'll get to that in a little bit here. First of all, we are going to take apart Flop, steal the drive motors out of it, because we need them for Strange Young Man. I have already liberated one. It is around here somewhere. I have a lot of stuff kind of in and around where I'm sitting right now, if you can't already tell from the mess that surrounds me. It has been a busy week trying to get these robots done, or this particular robot done. And that has led to some mess in my house. Alright, is this gonna go? Okay, well, I should actually show you what I'm doing here. So there is a new pulley system over here on this particular drive wheel. And I'm trying to get that off, but it does not. I think I have the wrong Allen key. That's probably the right Allen key in here. Yes, because I've been doing some testing with Flop here, getting things ready for Strange Young Man. So I've actually got these things, which if I hold one of these up, these are like flange couplers or something, I think they're called. And they are what we're currently going to, well, what we're going to be using for the drive system to fix the issues that Flop had with not being able to drive, basically. Because that was a big, big issue. Yeah. Anyway, got to get back to actually getting these grub screws out. There are grub screws down in here somewhere, I swear. Or maybe there's not one in this side. That could be an issue. Oh, I didn't Loctite these in, so them disappearing isn't super hard to understand. Neither of those seem to be the job, so let's see if we can get... I do not know what's going on with this grub screw. Or is there not a grub screw in this side? Is there not a grub screw on either side? Why is it stuck then? That is a little bit odd. It does not seem to want to come off, despite the fact that there is nothing holding it in place right now. Do I have a flathead screwdriver nearby? No. Damn. Alright. Well, I think we're going to just try and lever this off a different way. Actually, I've got bits here. So we'll try that instead. Where's a good flathead bit? That one will do the job. Very confused as to why this has decided not to come off. Yeah, it's literally got no grub screws in it. It really shouldn't be this hard to get this thing off. Alright. I mean, these motor shafts are pretty bent and banged up, so maybe it's got caught on something. That's rather annoying, to be honest. There isn't any Loctite or anything in these, so it's not like I can just heat it and it will move. Alright, I think let's move on and do the other side, because the other side should be easier to do. Throw this around here, making all of the bad scraping sounds for you. Yeah. Okay, lid was only on with a little bit, that's good. So we've got two motors in here. This one we're probably going to need to remove all of this setup. Which do I have? The right wrenches, maybe. That's a 13, good. We'll be able to do that then. Let's get this motor out first, which should be as easy as flicking this up this way. And taking some screws out. No idea what this is going to look like. Is this going to look alright? Oh, no, we're just getting shirt off the face cam. That's kind of going to be how that goes for a second. Also, let me know too if the audio is weird in any way, and I will try and fix things as I go. Still not fully set up for streaming, really. Probably should actually do a mic pack for streaming. That might work a little bit better, I would say. But it's not something I'm actually set up for at the moment, so... I've got a static mic and I'm going to be moving around a little bit, which will mean that things will change in volume as we go. Alright, I probably could have used the electric screwdriver for this, but I am a little bit concerned about stripping any of these screws here, because, well, I do have spares of them, but keeping them is a better option than having to get spares constantly. Alright. That's one. There we go. One motor. Done. That's good. Next up, we need this back wheel off, because that wheel currently blocks this hub from coming off, and that hub blocks everything else from coming off. So, next up, basically... how am I going to do this? I didn't bring all of my tools out here with me, and I really should have. Hey Jevon, how's it going? I'm assuming it's early morning there in the UK. So, it would be Monday morning too, so you're probably going to be heading off to work, hey? Alright, how are we going here? Yeah, this is going to take half a second. I really wish I had brought the ratcheting driver out here, but I did not. Am I going the wrong way? I think I might be going the wrong way. Yep, I've been going the wrong way this whole time. Cool, 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 cool. That's what I like to see. Also, I'm doing this semi-blind here. Because I'm keeping it facing towards the camera and not towards myself. I can look at it if I go over there. Public holiday in the UK. Oh yeah, it was a public holiday here too. I mean, I actually worked it, but that's only because I'm taking the public holiday in lieu later on, so just made my life a little easier for a second. Alright, let's go that way. Midday. Right, okay. Oh, that's right. Yeah, time zones have shifted again, haven't they? Bloody... daylight savings times messes all that up. Constantly. It'd be so much easier if we just didn't do that. Yeah, hopefully everybody's having a good Easter. It's basically over here in Australia. It's now 8 PM, or 9 PM basically. Just after 9 PM Monday here. Yeah, Yeah. So, yes, that's the Brisbane time zone. Adelaide is slightly further back in time than Brisbane is. So, we're not quite 9 o'clock yet. Getting there, though. All right, that should come off now. Yes, look at that. Thank you. Oh. There is a reason I tend to fast forward a lot of this when I'm doing videos. It's because there is a lot of just doing the same thing over and over and over again. All right, have we got a slot key in this? No, we don't have a slot key in this. We've probably got a couple of grub screws in it though. So there's a screw here, which I don't know that this one's doing anything, but we'll take it out anyway. And then, oh, there is another screw here. Same deal. I had no idea if this is actually holding anything, but we'll take it out. And then we're going to have to try and pop this off. And it does seem like the other one, there's something keeping it in place. But, unlike the other one, this one's a soft plastic, so it does just come right off. Great! That is what I like to see. Now we're going to have to do the same thing again, where you're going to get shots of my t-shirt for half a second as I pull this motor off. Here. Yeah, making sure that's all kind of lined up. Beautiful. The problem with combat robots is that they typically require a lot of screws, and the ones that don't, they're actually kind of the nicer ones to build, I reckon, but don't do them very often. I've only really got a couple that have very few screws in them, and mostly those are unibody builds, which I actually quite like a good unibody build, but I don't do them very often. I think it's because it's more CAD work. And I sometimes prefer to just get building rather than CADing absolutely everything, which has happened with Strange Young Man, and it's caused problems, which again, we will get to in a minute once I've removed this last motor here. Now, I have literally no idea what is stopping this from coming off. Oh, it does feel like... That is somewhat annoying. Let's see if I can throw this around the other way. Get some stuff out of the way. Good thing about it being a slightly lighter robot, I can just kind of manhandle it a little bit. See if we can apply a lot of force with pliers. Oh, there we go. That had something happen. Whoa. I don't really know what is going on there. Let's take a freaking time travel. Yes, always. Every time you're talking to an Australian, there is time travel involved, and I love it. Structural googly eye. Yes, the googly eye is very structural, although when I had the anti-hammer armor on, I had to take the big googly eye off because otherwise using the weapon would actually have popped the googly eye off against the top armor, which would have been hilarious, but I kind of like the big googly eyes. Take out the grub screws, the chassis combust. Yeah, yep. Sometimes it do feel like that, hey. We lost that pulley. Let me see if I can find that. That was very dignified. I'm glad that the camera didn't see too much of that. But we do indeed have our pulley back out. It's looking quite good. Let's also just very quickly... yes, let's very quickly turn down here a little bit, and you can see what I see, which is that there is a mark on here about there. Sorry, looking again across this way is me looking at cameras and things and looking at my screen setup so I can see what I'm pointing at, because my camera, when connected to streaming software, refuses to show what it's looking at. I have to look at my streaming software. Anyway, yes, right about here there is a mark from the grub screw, which I think is a dig-in. It does really feel kind of like a dig in. So that's probably what caused that motor to, well, that pulley to be hard to take out effectively. Anyway, let's get this last motor out, because then we can put Flop aside and not talk about it again for probably 4 months or so. It will come back. I have plans to fight it in August if stuff happens and there is a featherweight competition here in Adelaide. There's discussion about that at the moment. Oh, sorry, featherweight sportsman competition in August. There's discussion about that at the moment. And it might happen, it might not. But if it does happen, I would love to get the multi-bot back out again. I've got plans for the upgrade already. It will probably be some laser cut Hardox actually to make the frame out next time, because one of the problems that this version faces is that the frame, wow, speaking good words today, the frame here is a little bit loosey-goosey, and I had to add some extra supports in various places to get this to actually be more rigid. Oh, that's right. I totally tamped the camera down and did not pull it back again. Let's pull back to about here for a second. There is extra bracing in the back here. This is just this is semi-structural bracing at the back to kind of keep the base plate rigid. And then there are some, which way do I go? That way. There's a piece of bracket in here that you can just about see that is also structural bracing. It holds these side walls parallel to the front plate and to the weapon assembly here. All right, let's go all the way back out like that. And we will now get rid of Flop. Goodbye, Flop. You're done for today. You've given me motors. That is all I needed. We now have 1, 2, and there should be 3 and 4 around somewhere. Well, there's 3. Those are the 3 that we got out, and I had one around here somewhere. But one of the reasons why I am currently green screened is behind me is an absolute mess. I have been, yes, building quite busily, and yes, the amount of stuff in my near vicinity is just ridiculous. Here we go. There's the 4th one. Bam. So this is what is going to be running Strange Young Man. We're going to be using these flanged couplings, as mentioned before. This is what that kind of looks like. Again, let's take a closer look at that, if we can. Yeah, look at that. So this is a flanged coupling. This is not going to be the final design. The final design will use heat insert nuts because those are going to be nicer and keep everything a little bit more together effectively. But yes, these flange couplings have grub screws in them which lock into the shafts a whole lot better than anything we tried with Flop. I did some drive testing. You will see the drive testing in an upcoming video, probably next week. If all goes according to plan, it will be next week anyway. But yes, these are working really well. Despite being PLA prints around the outside of this thing, they have held up rather well to a decent amount of testing right now. So pretty happy with all of those. All right, let's get back a little bit here. Cool. And the next thing we're going to do before we actually move on and talk about what is going on with Strange Young Man, because again, there is stuff happening with Strange Young Man, we have a very important thing to do, and that is build a Strange Young Man head. So here I have a brand new Strange Young Man head that is fresh off the printer and painter. This is another TPU print, so we can squidgy him around like this, and he should be okay. This one is actually good because it's a black TPU underneath. So the last version of this I did had a white TPU underneath, so as soon as it got flexed too many times, the paint cracked, and you could see it because they were white underneath, and it was very jarring in contrast. This being black underneath will look like kind of robot damage. Also, yes, my printer did not do a perfect job on this particular part. I really actually need to chamfer these rather than fillet them, because yeah, the underhangs here are a nightmare to print in TPU, and you really don't want to use support material in TPU because it's really, really hard to get off. Anyway, that is that, and then I've also got eye sockets, ears, and a mouth, And all of these are similarly printed in TPU. These are actually printed in a gray TPU and then spray painted silver. So again, if they break and fleck, you're not going to actually see that too much. But all of this should now just glue together, and we should be good with that. The eyes, of course, will get LEDs in them. Probably not RGB LEDs. That was partially a joke. I would love to do that at some point in the future. But yeah, with the event rapidly approaching and the issues that we're about to talk about with Strange Young Man, I would prefer to work on the actual mechanics of the thing and not the light up RGB flashy googly eyes that we're going to put on him. Also, a Strange Young Man with googly eyes would be really cool. I would just need to put an activation light somewhere else. Maybe I should do that. Why haven't I done that? Huh. Just realizing, yes, I have never done a Strange Young Man with googly eyes, and I think that's a problem. I mean, look. We're just like... I think that googly eyes just a little bit too small here. Anyway, that's enough of that. Let's actually get on to some super gluing, because that's all we're going to do here. We're just going to super glue all of these parts together, which should be okay. It does seem like there's some super glue in that. If I can get it out is the next question. I don't have side cutters near me, so if it doesn't work, we'll just use a new one. That's fine, and I'll side cutter this later to get more glue out of it. And then here is literally just a cutting board, because of course they're HDPE, which means that glues and things don't really stick to them that well. I mean, this one is a little bit textured, so it probably will stick a little bit, but that's okay. Let's see, actually, can we get this piece of wire in here? See if we can get this glue open. Maybe. Come on. I don't think so. I think this one, we're just going to ditch this to the side for a second and use a new glue. Probably what I should have done in the first place. I mean, I'm just kind of building the way I would normally build. I probably should be building slightly faster because you guys are kind of here and watching me do things. And am I bringing spare heads? Yes, I am indeed bringing spare heads. So this is going to be the primary combat head. The old one that was the white TPU is going to be the backup, or one of the two backup heads. I do also have one in PLA that I might bring. If I can spare the time on the printer, I will print another version of this. It's just that this particular, this head is 24 hours of TPU printing. It's a lot. Yes. Also, hi Angus, how's things going? But yeah, hopefully, like I said, I'll get another spare head done, especially as this one, the print job isn't the best, and I would like a slightly better head, but, you know, this is the one that's going in combat, so at the end of the day, it's going to end up way more beaten up than it is right now, and we're all just going to have to be fine with that. I mean, it is what it is for at the end of the day. So, oh, okay, that was interesting. Usually TPU and superglue works really nicely. But that did not. Oh, is this because my chamfers are not quite right? Are you about to watch me glue my fingers together? Very possibly. There is more than a 0% chance that I glue my fingers either to themselves or to the robot at this point. That's alright. TPU, you're mad. Yeah, a little bit. Although I do have a Flexion extruder, so that does make life a little bit better in some respects with printing TPU. It's certainly way better now than it ever was before. I put the TPU on, the Flexion extruder on a Cocoon Create, and it's actually worked really well, to be honest. The head, like I said, it's a 24-hour print, and it prints at 45 millimeters a second is kind of the upper limit of what I'm printing flexibles in at the moment. But, you know, that's still pretty good. The original head, I think, took 2 days to print the first time I ever printed one, because I didn't chamfer all of my things in here. So I was actually printing support material like in the ears and in each eye and in the mouth hole and stuff. They took forever to print, and I'm very glad that I know more about printing and designing for printing stuff nowadays, because yeah, that's not something I ever want to do again, really. Yeah, long prints like that are just, outside of being time consuming and taking away from being able to print other parts for robots on the printer, they're just kind of nerve-wracking as well. Like going to bed and not knowing if your print is going to survive the night, especially with the early printers that were around the place, was just, yeah, kind of annoying. And again, slightly nerve-wracking. So I think this one's feeling like it's holding a little bit better, but I will throw a little bit more glue in the back like I did with the last one. Oh, that's interesting. Getting a little bit of green on the nozzle of the super glue here. So yeah. Oh, you might miss the event. Oh, that's a shame. I thought I saw you updating your robot though. Oh, you sent it with James. Okay. Yeah, okay. That makes sense. Is James working on his own feather? I don't know if he is or not. But it's cool to see him around the place and doing stuff. So yeah, I hope he does build his own feather sooner rather than later, especially now that we're getting more feather events. Have you brought in disposable gloves when super gluing? I haven't, mostly because I rarely glue my fingers together. Most of the time, if I'm starting to feel them stick, I kind of pull them apart, and I've definitely had times where I've like left film of super glue over my hands and it stayed there for like 3 days, and I'm like slowly picking it off. And that's annoying, and not the greatest thing in the world, but I deal with it. I probably should be wearing gloves doing this type of stuff. That is a good idea. I think this is definitely one of those do as I say and not as I do moments. Yeah. I like I said, it is slightly more rare for me to actually glue my hands together. So if I was more prone to doing that, I think I would be wearing gloves more often. Now, I should actually support this from the back too, because it's TPU, so it's flexing inside, and that means I'm not getting the pressure on the super glue that I really want here. One Ho i3 with Flexion was honestly one of the best Flexion combos ever used. Not fast, but reliable. Yeah, I mean, that's literally exactly what I have, and yeah, it's very, very reliable. I probably should upgrade my Cocoon Create, but I'd want to upgrade it to something I could stick the Flexion on that's going to be as reliable, and I don't know that that's a thing that I can find yet, or at least if it is, it's not something, like I haven't looked too deeply into what's on the market currently, so, and what would be good with the Flexion, because, yeah, I mean, I'm not sure if the Flexion's even, like, the thing for printing flexibles these days, or, like, the best thing to be using to be printing flexibles these days, but you know, it's working for me. It's producing lots and lots of parts. So here we go. These are all now nicely glued down. We're moving on to the ears, which, again, these are flexibles, printed in 2 parts and then glued together and then spray painted, because it was just easier than, again, trying to print support material in TPU, because any orientation you look at this, it needs some level of support unless you cut it and use it all together. And again, printing support materials and flexibles is just, it's nasty business. TPU loves to stick to itself. It will stick to itself like nothing else. So you have to cut support material away with a knife. Like you can't do anything else about it, really. Oh, this is the important one. This needs to be straight up and down here. And I need to hold it straight up and down until it glues. I hope that's close enough. Alright. No, just ants, but hopefully we can make him catch the bug. Yeah, I hope so too, because I mean, he built Bitzer in Adelaide while he was here, and I think he kind of enjoyed that. It'd be good to see him actually try, especially a sportsman. I think he'd make a crazy featherweight sportsman. I mean, give him that much weight, he's going to build something just crazy in general. Does ARC ever stream their events? No. It's just a case of we don't have somebody with the internet facilities to do that, and the club doesn't have enough money really to have an internet connection to use for, like, specifically for streaming. And realistically, I think if it wasn't for me, I don't know that club fights would end up online, really. It's not like Chris and James, while Chris did for a little while edit the fights and put some of them up. The ARC has its own YouTube channel. You can check it out. It does exist. However, it didn't really post much after about 2017, I want to say. So yeah, Chris posted stuff out there for a while, but just time and funding and stuff kind of got in the way of all of that. And realistically, like, ARC is it's a local club. It's not really an NRL type deal. Like, it's not put on to be a spectacle. It's put on because two guys really like combat robots and just want to give people in Adelaide the chance to fight combat robots. I think the only one that would maybe ever get streamed would be Havoc, because Robot Havoc is our big event of the year. That is our, like, let's put everything on display and do something really cool. So if anything would ever get streamed, it would be that. And honestly, again, on the money front, that would be a case of whichever event we were part of to do Havoc, because that is kind of what happens. Havoc gets put in or run at another event. We'd ask them to be the one, or, like, there'd be some deal struck where the person running the event would be like, hey, do you want to stream it? And then we'd say yes, or something like that, I think, for it to actually get streamed, really. But again, look, this is a Chris and James show. I am just talking from my own experience and what I've seen with the club. They could be thinking very differently to what I'm thinking right now, and I wouldn't really know, to be honest. Let's see. Oh, yes, people talking about different printers they have. Yeah, the XC1 looks pretty interesting. I don't really keep up with the 3D printing world all that often, mostly because I'm usually, using my printers to build things, like this Strange Young Man, which, if I got the ears straight, let's see. Yeah, mostly. I mean, enough that I'm happy with it. Look at him. And that should hold together pretty well. And if it doesn't, I mean, this is literally just super glue from Bunnings, the local hardware store, so I can easily get more of that at the event to put things back together. But yeah, that seems to have held quite well. Let's actually pack all of this up. Sport in the US, a lot of events stream, even if it's just one camera angle with no interaction and low quality. Yeah. So, I mean, and the other thing too, I feel like, I don't know, I feel like America on the technology front, it's just easier to access there in a lot of ways. And, like, I don't even know that the event that we have at the community center we go to, we could get access to Wi-Fi or something. Whereas I feel like that's a different thing in America. I feel like if you're in a community center, it's got Wi-Fi or something like that, or it's cheaper and easier to do. I don't know. I might be wrong on this, but it does kind of feel that way. Chosu's saying that you have time to edit fights and you've been thinking about volunteering. I mean, yeah, talk to Chris or James about it then. I mean, they don't set up cameras anymore. ARC have their own GoPros and stuff that used to get permanent fixtures on the arena. And for a while, I was doing that. I was setting up all the cameras before and taking them all down afterwards and copying all the footage over and then giving it back to them for use for editing and stuff. But I kind of stopped doing that a little while back because, nothing has really been done with that. And I didn't really want it to be a pressure. Like, I didn't want to be handing this footage over and then Chris or James being like, oh shit, well, we've got this footage, we need to do something with it. But yeah, I mean, it doesn't need that much editing, really. It needs to be like cut down and then background scrubbed and stuff so that you can't see the viewers of the combat, because yeah, there's lots of kids and stuff in the background, which not a good idea to do that, especially not without media release forms. And there is no way known that we're going to do media release forms for everybody that comes through, and yeah, that's just a massive hassle. Anyway, yeah, we've now got a new head. This is going to be real good. I mean, I love how flexible you can get this stuff. I cannot wait to see somebody drop a saw directly through the middle of this, because of course that is what is going to happen at some point in this event. And if it doesn't happen this event, it will happen the next one, because there's plenty of saws in the Featherweight Sportsman League, and one of them is bound to want to taste of this tasty TPU. Anyway, now we need to move on and actually look at Strange Young Man. It has been, I don't know how long we've been live for. We've been live for a little while, and I have been avoiding talking about this because today was supposed to be everything is ready. We're going to bolt all the parts on. We're going to have Strange Young Man going at the end of this stream. And instead, we're going to be problem solving together because I've got problems. So, let's get Strange Young Man. Ugh. This is Strange Young Man currently. As you can see, not in the healthiest of shape right now. Give me half a second, need to find some other parts. This is one of the other parts. Ooh. Bang, crash, clash. I missed entirely. Where is... Oh, it's out the back. Okay, I need to turn this whole thing around so you can see what on earth is going on. And, hit the microphone while I do, so that the audio quality is even worse than it has been for the first bit of this stream. Right. So, here we go. This is the new version of Strange Young Man. As you can see, there have been some upgrades for those of you who have been around long enough to know the old version of Strange Young Man. The old version of Strange Young Man used aluminium as a base plate material, and the same axle and weapon setup and stuff as this. Yeah, the aluminium was bad because it meant that every time I tried to lift somebody, the whole chassis tacoed effectively, because the aluminium was not strong enough to resist the bend force, especially when the arms here, which, do I have the arms nearby? Oh, yes I do. Dropping everything today. So here is one of the arms. It clears the chassis like that. Oh, you can't see that because I am in the way. That's the problem with having a desk cam and a face cam at the same time. Here we go. So it clears the chassis like this, and then on top of that we have the lifting arms. And again, just dropping everything all over the place. We have the lifting arms, and so this whole thing is really, really quite long. And one of the first things you learn about torque is that the longer the lever arm that you're using, the more torque you need to lift the same weight. And this is a massive lever arm. It's something along the lines of 40 centimeters between the actual bar and the tip of the lifting edge. Actually, let's see if we can measure that. Let's take a look. Yes, I do have a ruler here. Hello, Jordan. How's things going? Yes, it's hard not to find Wi-Fi here. It's everywhere. Cool, yeah, so that was my assumption on America. I'm glad that that's kind of the same, that's kind of validated. The base plate looks funky fresh. Yes, this is fully Hardox base plate. This should do a really, really good job. So we're just going to very crudely measure this. We're 30 centimeters from the axle to here, and then that's roughly there. Let's lean over everything and break all of the things. Another 12 centimeters, so 43 centimeters, or 430 millimeters. That's a lot. And it means that there is a lot of force required to actually raise another robot up here. And that was what was tacoing the base plate before. So Hardock's base plate to try and fix that issue. The problem then was getting the torque there. So this here, dropping more things, this here is a 40 something. Wait, I've got a copy of the motor because there is a motor in underneath this plastic section. It is one of these, a 4248, and it's not focusing on that at all, 650 kV. That is the motor that is in here. And then this giant block that you see ahead of it is a gearbox. It is a planetary gearbox. It's either 300 to 1 or it's 150 to 1. I cannot remember exactly. All I remember is that the output shaft is going about the speed I wanted it to be going to lift another robot. And it has effectively all of the torque needed to do that. I think I roughly spec'd it for just over 13 kilos at the output shaft here to drive all of this. But of course, we're not going to direct drive off of this into the arms because the arm, or this crossbar up the front here, is often used to protect against other weapons. And in fact, if I flip this over, you can see there's all sorts of saw marks and cut marks and stuff in here because it gets beat up. So we don't want to be giving that punishment directly to our gearbox. So this has got a pulley on it, and I've mounted a pulley in here, and everything was supposed to work. Unfortunately, this is not the first pulley I put on. I've got other pulleys that have been attempted, and each one has had their own issues, unfortunately. So this one is a 1-to-1 with the actual pulley that sits on the arm, and I don't have enough space in here to make that work because I have to fit this motor in one exact spot, otherwise the wheel systems don't fit in, and even then it's still a little bit of a tight fit. This is not exact, this is just a mock-up. I was planning on cutting these out of aluminium today, but then the weapon system did not work, and did not work multiple times, unfortunately. Yeah, so this is kind of where we're at here, is that this didn't work multiple times, and then I finally got this. So this, I upgraded the tooth size to keep the belt on, because one of the problems with the smaller pulleys was that with this everything mounted down, I was actually getting the belt skipping rather than moving anything. And once I finally fixed that by increasing the pulley size and tightening everything down, and like it got to the point that you had to put one bolt in, squidge the belt on both of them, and then kind of eke it back and put the other bolt in, and then tightening down both bolts kind of locked and lowered and put a lot of pre-tension on the belt. Once I got that working, it worked for lifting Flop, the multi-bot, so it lifted about 8 kilos on the end of the forks, no worries. The second I tried to do anything heavier than that, so I tried to put on Very, Very Obvious, for example, which it's only a chassis at this point, but the actual chassis and the weapon together is probably around 10 kilos, 11 kilos. It's most of the weight of a featherweight. I actually stripped out the 2 screws holding down this particular motor. So that's an issue because I can't really foresee this being how we go about this. And yeah, despite the fact that there are multiple holes and I could put more bolts in, I feel like doing so is not going to fix the issue. So yeah, I've got a couple of options here and I'm not really sure where I'm going with them yet. Because again, all of this stuff kind of happened today, within the last like 3 hours effectively. So, I mean, I printed a bunch of stuff like overnight and during the day, and then, yeah, testing mostly happened this evening. And I printed backups of things and differences of things because I was like, well, I've got time on the printer and I've got limited testing time, so we've got to make sure that something works. Now, all of this is to say that Strange Young Man is probably not going to be a lifter for the Brisbane event, which is literally next weekend at time of streaming this. So rather than being a lifter, my goal is this. This is a hammer mech. The goofiest hammer mech that I've ever built in my entire life. Which, hang on, I'm going to get the drive motor out of here because, again, it's not really going to work. And I also want to show you this very, very goofy hammer mech that I designed a long time ago. This was a pre-pandemic build, this one. So this is literally a handle, a hammer with a plastic handle from the local hardware store with an M8 hole drilled in it that sits into some box section and gets bolted in there. Where are we? There we are. It is quite literally the silliest hammer that you can possibly build. And it mostly works. I kind of want to print a little TPU block to kind of hold the hammer a little bit squarer. And also because you can see I've used this once already and it's starting to bow. Yeah, it's starting to bow out this piece of tubing. So putting some TPU in there will just kind of like fix that a little bit and mean that I can run this for a full event without actually destroying this mechanism. Although it is quite cool to see the hammer kind of rock back and forth. And realistically, look, it might not be too bad. But yes, it's going to be very, very goofy with the hammer on like this. So yeah, this is the goal. The goal is to get this hammer on and get this hammer swinging quickly so that it works as a hammer does. We're effectively just going to be building a round-the-body hammer now rather than a round-the-body lifter. Right, so I've got a couple of different ways to achieve this goal. And one of them is really, really simple. So we're actually even going to try and do this together on camera in this stream, and I want to see how everything lines up and how the belts play and all of that, which is this. So this here is just a 5065 scooter motor. It's 140 kV. It has a Hall effect sensor in it. This could be perfect hooked up to a VESC with the Hall effect sensor running. It should be able to give a decent amount of torque at very, very low speed and then ramp that up, obviously. Yeah, so this could be the way to go here, and I've got some parts that might actually make this work. Alright, let's see. Where are we at? Hi, Razor, how's it going? Goofy bots are the best. Strange Hammerman, I like that. I like that a lot. Yeah, see you around, Angus. Have a good rest of your Easter, although it's very, very short at this point in time. Even sillier than the squeaky hammer. Ooh, that's a hard call. Although I do have the squeaky hammer next to me. As mentioned, I have a lot of robot parts around me at the moment. And you know what we could do? We could go real silly and duct tape the squeaky hammer. We could duct tape the squeaky hammer to the actual hammer. That would be ridiculous in a lot of ways. Oh, also, I've realized I was looking at how big Strange Young Man was, and I wasn't pulled all the way back, so you couldn't actually see how big Strange Young Man was. So there we go. We're now pulled all the way back. Now, I will say, going back to the issue at hand, the last version of Strange Young Man that was running scooter motors, skateboard motors, and it also had this issue, like it had the bananaing the base plate issue, which is why the lift didn't work then, and I tried to run a hammer, that hammer specifically, and it kind of sort of worked. I ended up changing it out for a lighter arm with a screwdriver in it and running it off of this brushless motor, so that's actually where part of this idea came from. But in that particular version, do I even have... yes, I've got that base plate. Hang on, half a second. I would show you that base plate and why that didn't work. As I said, I have a lot of mount the squeaky hammer. Okay, yeah, sure. I might even order a couple more squeaky hammers then. Squeaky hammer if there's a rumble, or the whole time. Yup. My dog's ears perked up when you squeak the hammer. There you go. Yeah, hang on, we'll see if we can get the dog back again. Where's the microphone? Anyway, so here is the old base plate. This is 3mm thick aluminium. This is why this tacoed. I have put a little bit of work into flattening it back out again since then. But yeah, it did not perform very well when using the lifting mech. So the last version, this version of Strange Young Man, went in with this brushless motor, attempting to do the hammer thing, but as mentioned, couldn't really swing the big hammer, so I ended up using a screwdriver. And even then, I had these slots cut in the base plate, and these were so that I could mount the motor and move it around a little bit and try and find the exact right spot to actually, like, you know, get the belt tension working. What I found with that is that no matter what I put into these slots or how many screws or whatever, I would always have the belt tension slide the motor forward. So after 2 swings of the hammer, the motor had slid forwards enough that the belt just started skipping rather than, you know, actually doing its job. So this base plate is now trash because it's not going to work at all, basically. And it's still got some test stuff from when I was working on the skateboard motors in it, because I was trying to get those to work a bit better. I had problems with them in this particular version, and I printed some blocks up that actually helped a little bit, but those skateboard motors are now way more expensive than they were in the past. So we're not using those anymore. Instead, we're using the new stuff, which is cheaper and easier and doesn't require VESCs to run literally every motor in the robot, because wow, that was a crazy thing to have done. For one build was to run VESCs for everything. That was just... I shouldn't have done that, basically. He wagged his tail. Nice! I've got a few squeaky hammers left over from saying the name of your robot is hard. Positively hysterical. I'll put some hot glue over the whistle and put some squeakers from dog toys in there. Oh yeah, that's not a bad idea. I mean, and that, I think I mentioned in the video where I looked at this, that is what I expected. I expected these to just have like a little like dog toy squeaker in the end of them and not whistles. But I was positive, like I was surprised, pleasantly surprised, I would say, because these make a cool noise, I feel. Yeah. Also, I was going to ask too about positively hysterical. Did you put the squeaky hammers on after I did the squeaky hammer, or would you already kind of working on that? Because yeah, if that was an inspired thing from one of my videos, that's pretty cool. I'm glad that, you know, you saw that and went, hey, that's what I want to do. Yeah. What does VESC mean? Okay. VESC is VESC. Do I have a VESC? Yes, I have a VESC. So this here, let's zoom down on this real quick. This is so this here is a VESC. It's known as a VESC because they're made by a guy called, well, the original versions of them were made by a guy called Benjamin Vader, and he's still working on them. This is an older one. This is a VESC 4.1 or 4.2. It actually came from Hobby King originally. But the specialty thing about these is that these are a 50 amp 12S ESC that are fully programmable. So there is a software tool that you can use to program them to do all sorts of different things, including this one has a port on it to have Hall effect sensors plug in, and then it knows from the Hall effect sensor where the motor is and where to apply power, so it actually has more power at low end speeds, which is something that most brushless speed controllers struggle with. And again, these, like I said, I think they're an open source thing, because again, this one came from Hobby King. It was a Hobby King clone of the VESC. The other really cool thing about these, which I would have to set up some stuff to show you how it all happens, but when you plug these in, there are wizards for setting up motor spec and also controller spec. So you actually can go into the thing and be like, hey, I've plugged you into a new motor. You work out the settings that make this work the best. And it will spin the motor up and down a little bit, and it will work out a setting that it thinks works well for it to spin the motor up. And then you can apply that to the speed controller, and it will just use that from there on out. Sometimes they do need a little bit of tweaking here and there, and a lot of the time, like especially if you're using the drive, they need a little bit of tweaking, and there are much better people out there than me at tweaking Vesks. I am not super good at it at this point in time. But yeah, they're just a cool speed controller. And also, so like Death Roll, for example, uses basically these exact speed controllers to drive its hub motors. They're pretty good. And a lot of the BattleBots teams that are running brushless stuff will be running Vesks somewhere in their robot because they're just good at what they do effectively. We came up with the idea separately at the same time. Oh yeah, that happens. What's it called? Convergent thinking? Yeah, something along those lines. That's cool though. I love that idea. I want to see more people put squeaky hammers on combat robots. So when I saw you'd already done that, I was like, yes, well done. Well done. I love that. Please do more, basically. Speaking of doing more, I'm actually probably going to rebuild my version of the squeaky hammer at some point because I've thought of a way of making it louder, so I kind of want to do that, basically. And we might do a CAD stream at some point in the near future to redo the chassis to fit in a new mechanism that will allow the hammer to swing faster and better and hit harder and kind of hit more parallel than it's hitting at the moment. At the moment, it hits at a bit of an angle, so it's not getting a nice compression on the hammerhead. So I really want to change that up a little bit and make things just work that little bit better. Anyway, we were here to work on Strange Young Man, so that is what I'm going to do. I'm going to try this motor system out, see if I can find a spot on the Strange Young Man chassis that is going to work with this and is going to make everything sit down nicely, and see if we can get a belt tension on here that will be able to swing that hammer, because again, there's a lot of force on this. Even the hammer is quite difficult. These smaller pulleys, when they didn't have the belt tension in here, even with the heavier motor, which, can you see that? No, you can't. I need to stop zooming in because I'm not, yeah. I keep zooming in and then forgetting to zoom back out again and like gesturing to things all over the desk here. But yeah, so even with this really powerful motor, these smaller pulleys here didn't hold the tension on the belt enough, and even swinging the hammer around was hard to do. And that hammer is like a kilo, and it was skipping the belt at that point. Yeah, so belt tension is everything here. It's really makes or breaks whether or not this system actually works. Now, next thing we're going to do, we're going to take some of this stuff away because we don't need the arms around while we're working on this thing. They are just to help us kind of measure stuff out a little bit. And we don't need these pulleys anymore. We can get rid of all of those. Just, doing some cleaning at the same time. My previous weapon had been rubber stamps that left cat paw prints, but YouTube comments mentioned it looked a little bit like an oppressive salute. Oh, yeah. Yeah, that... I can unfortunately see that. I mean, I don't really agree. I mean, yeah, I feel like that's on the edge there a little bit. Like, it's not exactly that, but it could be mistaken for, I guess, is what I would say there. Now, what I should try and do... Oh, where'd the bigger pulley go? There it is. This is our bigger pulley. So this is our biggest pulley that I have, which fits over here. This combined with this, I think is about a 4-to-1 ratio, something along those lines. That's all the ratio we're going to get to swing this hammer, maybe, but it should be enough, I think. Also, yes, this thing is very, very beat up. It actually started its life as the very, very obvious pulley, and it got hit by the weapon it was spinning a number of times. But, you know, that's fine. It's still okay. Am I going 1-to-1 with the pulley ratios? That was the plan with this thing when I was looking at doing the lifter. When this... oh, wow. This gearbox does output the right speed that I wanted to be able to lift somebody with, and again, approximately the right amount of torque. So I was going to go 1-to-1, but then trying to fit everything in, the 1-to-1 pulleys didn't fit very well, so I put the smaller ones on, and they didn't work very well. And then, yeah, if we're going to swing the hammer with this boy, then we're definitely going to want some gear ratio, basically as much as we can. And I think this pulley is about as small as we're going to get on here before we have issues. And also, it's a nice steel pulley, so I can actually mount this really easily. It's already got a grub screw in it. I don't have to worry about machining anything, making something new. Yeah, and having issues with that holding onto the shaft. Like, this will lock in here. No worries. We should be totally fine on that. So, yes, next thing is going to be to get this setup off here. And then we can work out where exactly we need this big pulley. Because I've got this spacer block in here, which may not be needed. I hope it's not needed, or at least something not as long as this, because this is a little bit ridiculous, to be perfectly honest. And the longer this is, the more force is on these screws, or more torsional force is on these screws, and that's not particularly good for them, even though these are high tensile ones. They will eventually shear or twist themselves around the axle, I guess, which, again, would not be good. Probably actually need to, at some point in the future, get a new disc cut for this particular arm and weld that on, or just make a new one entirely, because this one is actually the same original arm or original weapon axle from the very first version of Strange Young Man, which I built over in Perth with a friend of mine, who he had a machine shop at his work, and his work very kindly let us build the very first version of Strange Young Man there over a weekend. And that was really, really good fun. Getting to hang out with him and build an interesting robot together. It's really, really good. Not a lot has stayed the same about Strange Young Man since then, and my engineering choices are nowhere near as good as his, but yes, some of it has, and that some of it at the moment is this arm, or this axle setup, which is quite cool. It was safer just to change it and avoid it entirely. Hammers are funnier anyway. Yeah, I agree with that. I think I need to fundamentally change how that system works, and I think part of that will be rejigging it so that I like gear drive or something and do like flexible gearing somehow. Whoops, that's not what I want to do. Yeah, so have like a semi-flexible gear on the output shaft of the motor, and then a rigid gear on here, and again have a new mount point for the pulleys, or get that right in CAD, because yes, I kind of messed this up. I had this part in CAD further over than it actually is, which is why the bolt hole spacing is wrong here. I also think I might have done that. I maybe think I like centered this when I did V3 of Strange Young Man. I think I centered this in CAD and then just moved this to meet where that was now sitting. And that was a bad idea. You should CAD the things that you actually physically have and not the things you want to physically have. Right, so this is now mostly apart, so let's do the next thing here, which I think is to get Where did I put... I brought screws in earlier in the day. Oh, there they are. Right next to me. Totally blind, apparently. So we're going to mount this guy up to the mounting bracket for it, which... Again, the totally blind thing is striking. Oh, there it is. That's our mounting bracket. Also, it doesn't help that I've got so much stuff around me at this point. Yeah. If you're a messy builder, same. I get to a point halfway or, midway through a build and my tables just look like this. And I do mean tables, multiple. Yeah, again, there are tables behind me that you can't see that I've also got other stuff on them for getting Strange Young Man working. And probably I'll have to clean my house when I get home from the weekend. Anyway, that's going to be a future me problem. For now, we're going to mount up this motor and ignore that problem. Is the name a reference to anything? Yes. Yes, it is. So the name is one of my earliest robot names, actually. And way, way back when I first started robot building, all of my names were lines from Back to the Future that you couldn't tell were from Back to the Future. So, like, my very first robot was called Make Like a Tree, after the joke that Biff fails to tell constantly in the Back to the Future series. My second was Don't Need Roads, which is a clearer Back to the Future reference. Strange Young Man is also a Back to the Future reference. It's actually when Marty goes back in time and ends up getting hit by his grandfather's car instead of his dad. He goes to dinner with his grandparents and his mum, and then makes some excuses and leaves because things are getting weird with his mum. And as he runs out the door, it's either his grandma or his grandpa basically is like, that's a strange young man. And so that is where the name of Strange Young Man came from. Literally from a Back to the Future quote that's, again, not like a Back to the Future quote that most people would be like, oh, I know exactly where that's from now. Whereas I feel like Don't Need Roads really is a Back to the Future quote where people are like, oh yeah, I get that. That's a Back to the Future quote. Yes. I keep building more workbenches instead of getting more space. Everything spreads out. Yeah, I get that. I very, very get that. Why not make a hammer saw configuration switchback style? That is an interesting idea. The problem for me is, yeah, it's more a problem of mounting at the moment. I've got I've got 3 arms. I've got the 2 that you've seen, this one, and the hammer. And then I've got another one, which is literally just an aluminium angle that's about the same length as this. And none of those are super conducive to actually doing a hammer saw type thing. I could do a hammer saw with Strange Young Man. It totally would work. I'd want to do something really, really, really silly with it, though. Like, make the hammer saw be an actual circular saw that's held onto the arms in some way. But that is a thing for another day entirely, because I do not have the time or mental energy at this point to think about where or how or what that would look like, really. So with this, we've got a couple of different options. We can either mount it this way, which that's going to be so far off base for where this sits. Come on, go back. That's the other thing. I actually probably need to find time to get this shaft on a lathe, because there are certain points that get real sticky in these pillow blocks, and they are pillow blocks? Sway bar mounts. I think sway bar mounts is what they are. They're not something that I was super familiar with before building Strange Young Man. Right, okay. That I can't do for a number of reasons. One, it's way, way far out this way. and 2, it does contact here. So we need to go the other way, which I have not set this up for that, but that's fine. Can swing this round in a second. Oh, okay. Yeah. That actually will work pretty well, because then we can basically mount the pulley directly to here, I think. Yeah, okay. I think that is the go, actually. So I am going to set this up slightly differently. I mean, I literally just put this together, but we're going to take it back apart again now. And move where the cables are coming out from, because that is going to be important. Because currently they foul the axle, which we don't want, because then we're going to have cable wrapped around the axle, which is no good. And I did mention I do have a second option here, but the second option is way more labor intensive, or way more potentially labor intensive. Yeah. And I mean, it could work, but I feel like, given that we are literally like 4 days away, it's going to take a day at least to get it to work. And then if it doesn't, then I am, 3 days out from an event with no real plan, which is not somewhere that I like being particularly. So we'll just work on this, because again, we can probably get this working this evening even, or at least I hope so. Oh, yeah, no. Actually, I'm going to say we'll get this working this evening. Probably not an actual powered on test, because there is no way that I'm powering on this robot, especially not with a motor like this attached to it, inside my house on this workbench, especially without safety glasses. But even with safety glasses, that's a very silly idea. This is not a safe testing environment by any stretch of the imagination. So we're not going to do that, and that bolt just refuses to go in. So for now, we're going to ignore it. Because, sometimes number of bolts is just a suggestion. Okay. Oh, that could be a problem. I hope that's not a problem. I need to cut this corner here. It's this one. Need to cut that off. Yes. Or a Hydra Moose antler configuration so you control your opponents. I'm assuming, Razor, the no is for the Hydra Moose antler style configuration, because yeah, no, sorry, that's not a happening thing. I'm not doing that. I'll take the blows to the head, because that is mostly what the head is there for, really, and leave that to Hydra. Yeah. So you panic at 2 weeks out. Yeah. Look, there is a reason that the channel name is Team Panic. First of all, it's a reference to Hitchhiker's Guide. And second of all, that was a thing for me, was panicking the day of or 2 days before an event was very, very common for me. And part of the reason that Team Panic exists in the first place is because I was doing that too often. I was just getting close to an event and realizing I had a month. I'd had a month to build stuff and done nothing with that time. And I was now 3 days out from an event, and I had a whole new version of the robot that I'd wanted to build. And the old robot was in pieces anyway, so I needed to do something. And I was rush building 2 days before the event. And so Team Panic started. I didn't actually have a team name for the longest time, and it was only when I started the channel that I had a team name. And I started the channel so that every week I put up a video, and every week some robot combat stuff happened in my household. I made sure that I was always tinkering with things and always pulling things apart and always repairing things and working on robots effectively. So yeah, Team Panic has this weird history of being both named because of and partially the solution to a problem I was facing at the time. I mean, as you can very clearly tell, I still do panic from time to time, so the name is still rather apt. But yeah, working on things constantly and having YouTube videos out mostly every week does help with that a little bit. Although, again, sometimes videos don't happen. There is a video sitting over that way, just off the desk, that was supposed to come out this weekend, and unfortunately, life things happened, and it just didn't happen. I was just busy with a lot of other things that needed to happen, and so that video is happening at some point in the future, but it did not happen this weekend. So yeah, and I think Strange Young Man build will be next week. So that one's probably, I don't know, might even be a month away now because it missed its slot in my filming schedule. So these things happen. All right, good night, Josie. That was me at the last event. It was way too stressful for me. It was also my first event running 2 robots. Yeah. Look, I mean, running multiple robots does exacerbate things quite a lot. It's not a linear thing. It's a exponential thing. The more robots you have, the more work you have ahead of you, both in terms of the actual build process, but also keeping them all running. Yeah, I mean, having said that, you can go to an event and find that, life is great and things are fine, and you're running, 6 robots and everything's cool. And it will be like that all the way up until you have 4 robots die all at once, and then you're just in a nightmare scenario because, yeah, trying to work on 4 robots simultaneously, something's got to give. You just end up like running one of them out of 4 and fixing that and deciding that everything else gets put by the wayside effectively. I've never been in quite that bad a situation, but I have been in situations where I've had multiple robots go down at the same time, and I've had to just kind of like prioritize one over the other. I mean, the best example of that was the last Plastics. The last Ants League for ARC, because I had trouble with the main design. Did I? Yes. Yeah. So I had 2 robots in there, and it wasn't even. It was the Beetles, because I was running the Melty Brain and I was running Exilus, and Exilus went down and the Melty Brain went down a little bit, and Exilus just kind of got put to the wayside and left to fight in its configuration. It wasn't down, it was just the drive mixing messed up all of a sudden, and rather than fix that, I worked on the Melty Brain. Because I was enjoying the Melty Brain, and still do. I love the Melty Brain, it's good fun. But yeah, something's got to give when multiple robots don't work at the same time. Racer doesn't like defensive frames. Yeah, I can understand that. I mean, if you do it to the extreme, and I feel like that fight was a fairly to the extreme example, it is a little boring, or a lot boring of a fight. I mean, sure, it's a strategic play and you've done it for a reason, and, you got out of it what you wanted to get out of it. You didn't get hit, but at the same time, part of combat robots is that it's a spectator sport, and a big defensive frame isn't great for spectators. I mean, it's great for the first, 30 seconds of you using it, and the spectator's like, oh, yeah, that's really smart. But if it works too well, and your opponent doesn't blow through it, then it gets really boring really quickly. But of course, you don't want your opponent to blow through it if you're using a setup like that. The whole idea of it is to build something that doesn't break. Yeah. Anyway, minor rant on that. I don't begrudge them doing that. I can see why they did it. It's just, for me personally, I wouldn't do something similar. A big defensive frame, nah. I'm good. Yeah. I'll take the shot on the chin and blow to pieces and, have a spectacular highlight reel that you can look at. Literally Hypershock's team. I'm assuming that is in reference to the fact that I build very, very last minute, because Hypershock always seem to be doing something very similar. What's the likelihood of a Beetle Ant rebuild of Don't Need Roads? That's a good question. Possible. I'd say possible at the moment. Look, for those of you who haven't seen it, which I would assume that those of you, like people here, have seen it, the very new, very, very dangerous Lojinx here is my current Antweight A division bot, and I'm not expecting this to last past an event. I'm expecting it maybe not even to last past a fight. It may go into a fight and self-destruct. So given that once this robot has apexed itself and is in many, many pieces, we will probably end up building something new for the A division. I haven't fully decided what I wanted to do there, but a Don't Need Roads, a new Don't Need Roads has been on my list for a little while, especially knowing what I know now about building combat robots. I think I would change up a few things that I did in the old version, and I did mid-pandemic sometime. I CAD'd a new, lower, wider version of Don't Need Roads, which is really interesting. And I might work on it, especially now that I've done something like this, which is the lowest, thinnest robot I've ever made. I might try and take a chassis like this and mount a drum to it and see how we go from there, because I think that could be quite interesting. Anyway, the answer is maybe, and it will probably be to fill the void left by Lojinx when Lojinx apexes itself, effectively. Because again, kind of expecting that at some point. You're painting a dragon while I'm tinkering. Okay, what kind of dragon? Is it a, D&D mini or something along those lines? I bought 2 US Ants and 2 fairies for the last event. I had to forfeit 1 fairy to steal parts to get the other running. Yeah, that'll happen for sure. Yeah, I am in no way surprised. As somebody who has run 4, 5, 6 robots at an event before, I understand. I know exactly where you're coming from. And I need to stop bumping the microphone. Hopefully that's not too bad for you guys when I bump the microphone that is literally right here in front of me. It's actually coming up. Oh yeah, you can see the pop filter on the face cam here. Yeah, all right, let's see. If we mount this down here like that, where do we need to mount the pulley? We need to mount the pulley quite far out, actually. All right, where's the flat of that shaft? There it is. I'm kind of trying to do this over top of everything so that you all can see, even though I can't really. Oh, okay. That actually lines up pretty nicely. Interesting. So, I think first of all, let's get the grub screw tightened down on this motor shaft so that it stays in place. Now, I have no idea which Allen key this is, or if this is even going to move. It did have Loctite in it last time it was used. That's too big. Let's be a little neat while I've got so many robot parts around me. Okay, yeah, here we go. So let's go down as. Oh yeah, that's definitely got some Loctite in it. I may have to pause here and. Oh. Okay. Oh no, that's just stripping my Allen key. Okay, I don't think this is the right size Allen key. I think this is the metric or the imperial closest to this, but not the actual thing. That's somewhat annoying. Oh. Just got a metal shard in my finger. So there you go. Didn't glue my hands together. Did get a metal shard into my hand. For from playing with a very, very sharp pulley. Bound to happen, really. Okay, what am I going to do about this? Because I didn't bring loads and loads of Allen keys out here. I thought that I should have everything covered by what was around me. You know what? We're not going to worry about it. We're just going to... stop bumping the microphone. We're going to put it on, and we're going to set everything in place and see what the belt tension situation is like. So let's go like that. Oh, okay. Wow, that's... Oh, this is going to be tight. That's going to be good. In fact, that might be too tight. Yeah, that might actually not work. Let's try and find out, shall we? So the best way to do this is going to be to take some bolts, and we're going to have to do this the right way around because, of course, this pulley could fall off at any moment. And again, sorry, you're going to get t-shirt on the face cam for a second. And bad audio. I'm going to try and set myself up here. Okay. Now, this may be too tight, and if it is, I do have a slightly longer belt. Is this still in frame? Yes, my hand is in the way. I'm sorry, you're not going to be able to really see what I'm doing. I am putting in a bolt. One of two that hold this in place. Of course, the problem with this is that once we get this tightened down, it's going to be real tight. Like, this belt is going to be ridiculously tight. So much so that it may not even actually tighten down all the way. And we might need to get a bigger belt, which I do have a bigger belt. I think. Is this a bigger belt? Yes, that's a bigger belt. How many times can I say bigger belt in 30 seconds? All right, we're going to try and put this other bolt in. So hang on. Let's get you guys a better look at this. Looking at Lojinx, I can imagine a Walker Shuffler Ant or just a Beetle version, but that with that weapon as a vert. Yeah, I mean, it's definitely much better sized to a kind of Beetle or a US Ant. I think that's more what it's actually for. But, you know, I had to do the crazy thing and put it into an Australian ant weight. Now, let's see if I can show you what I'm doing here. All the way down. So, here we are. Down at the bottom here. So there is a bolt hole in underneath here, and there is a bolt hole there. And to push all of this down will tension that belt real nice. But I have a feeling it's not actually going to work. I have a feeling this bolt is not going to want to go in there, and if it does, it's not going to tighten. Yeah, okay. Not sure if you can see that. I can get it in there, but there's barely enough room for a thread. Yeah, that's not going to do the job. All right, let's pull some stuff back apart for half a second and put the longer... there we go. Put the longer belt in and see if we can get that working. Okay. Let me sit down too, so that you're not getting t-shirt in the face cam. Or this kind of like weird amorphous, some t-shirt and some not t-shirt. Have I ever tried the game Robot Rumble 2? No, I haven't actually played it myself. I've seen it, I've seen videos of it, I'm aware of it, I just haven't actually played it myself. I did see people commenting that the Strange Young Man gamer should have been playing Robot Arena 2. And yeah, probably actually. I just played a game that I had on my computer already with that. Rather than try something new, basically. Speaking of Back to the Future, you're fading away, at least your face cam. Yeah, so that is because I stood up. So the face cam is one of those like NVIDIA background remover things, and it does an okay job when there's a face in the frame, but as soon as like there's pieces of t-shirt and stuff, it doesn't know what that is, and it just like removes them, kind of. And you end up with that, yeah, weird half a human thing that happened just before. So, all right, let's try this slightly longer belt. Once I get the arm back in the point where it moves again. I also, not sure if they show up on camera. Oh, of course, I've bloody zoomed in and forgot to zoom back out again. Constant problem on this particular stream. There are markings, and of course, I'm pointing at the one you can't see. I've got Sharpie marks. Hang on, let me move it that way. Yeah, so I've got Sharpie marks that line up with where this bar needs to sit to be even across the length of the robot. Because at the moment, nothing is holding it there. I think we'll put like clamps, pipe clamps on it. The old version literally just had wraps of tape to do that job, but it meant that to take the arm out, you had to unwrap one of the wraps of tape, or you had to remove both of the motor mounts. The sway bar mounts, these things. And neither of those solutions were that good. So we're going to try something, proper this time, is what I want to say. Oh, wow. I can tell already that's not going to... Look how much slack is in the belt. So much slack in the belt. Yeah, that's not going to work. And we can't really move back much further here. We could maybe put on a bigger... Maybe we do move back a little further. Are we going to be able to do that is the question. Actually, it doesn't look like it. It looks like to go back that far... First of all, we're going to be interfering with where the motor sits back here for this drive pod, which... Hang on. There's my template. Yeah, we're interfering with where that needs to sit. That's not great. Yeah, no, okay, we can't do that. So this belt is just too big. So, what can I do here? Because I need to be able to sit about there. Now, I might be able to get some more height out of this. That's something we can look at right now. So let's do that. Body panel. Here's a body panel, one of the old body panels. These will still fit this new design. It has been designed to take the same size body panels. So we're going to take off this bracket because this bracket A is not needed and B does not fit anymore. Come on. There we go. Of course, it's being held in by a nylock, but also by paint sticking between the two materials. Because these are just painted this very specific green, which I found out you can't get anymore. So I've got one can left of this green. So next year's version of Strange Young Man, whenever I build that, may have to change green, which is disappointing. Oh, who knows? Maybe I'll find a different brand of spray paint that makes the same green. That would be real nice. Any room for a tensioner? It would be difficult, is the answer to that question. It'd be very, very difficult. Because there's not really a lot of room in here anyway. So, alright, let's just pop all of this off for the moment. Okay, so that's higher than it needs to be. It needs to be there. How can I test where the thing is? Oh, I know. The easy way. Let's throw this all the way over here. Do this. Hopefully we can even grab some M8 bolts. I've got another M8 bolt. I've got to have another M8 bolt. Yes. Cool, that's our M8s. We can actually throw nuts on those. Just to kind of rough this out a little bit. These are nylocks, but it doesn't really matter that I can't tighten them down fully with my fingers. Okay. And then all we're going to do is going to move this way. Right. So, oh, that is basically just the right size. Couldn't you turn the bolted holes into slots and then adjust the tension? Yeah, so I'm assuming you missed a little bit of the stream earlier. So first of all, this is Hardox. So actually making these slots would be a bit of a pain in the butt. And secondly, in the third iteration of this build, this was the aluminium base plate. I used slots in here, and what I found was that I got the tension right. I set the tension before every fight, and then after every fight, the motor had moved back like a mil, and that had released the belt tension again and stopped the arm from working. So I'm trying my very, very best here to not use belt tension to fix not use slots to fix belt tension issues. I'm trying to bolt things in exact positions and have them work first try, basically. So this, I'm going to see if I can get this in a way on camera that makes any sense so that you can kind of see what I'm looking at. Okay, I need to flip this around the other way. I'm working on my bidder right now too. Reprinting pause. Oh, cool. Working on placement of undercutter motor later. Nice. I have a bot chassis sitting on my printer finished. Too lazy to go get it and work on it. Oh, well, fair enough. I mean, it is a holiday in most parts of the world. Okay, let's see if I can get this on camera. You can see just about that this pulley basically sits right at the very top of the robot. Like if I push it too much higher, it will run into the lid of the robot. Yeah, that's a problem. So we can't go any bigger than this to take up slack in a belt. We have to use what we've got, which means what I'm wondering is maybe I go with the smaller pulley here. If I go back to this guy on here, and the smaller belt, if that will work. I mean, it's going to have a smaller gear ratio, so I'm going to have to test a lot to make sure that the motor can still do the right job. But that might be the go. In fact, right, actually, gonna get some water before I continue on here. Oh, okay. Lots of talking. Well, from me this evening. Typing from you out there. Okay. So, if we swap these parts over, I mean, the other thing too is that I could look at a new version of this that is just that little bit smaller, that would allow that smaller belt to fit in those holes that we looked at before. Again, it means dropping the belt tension, the ratio just slightly, which again, not great, but in this case, it should be okay because, again, we've got a vest with Hall effect sensors, so starting torque shouldn't be that big an issue. At least I hope it's not that big an issue. But let's get this pulley off again for the 100th time today. I've literally spent so much time today swapping pulleys over on this robot, trying to get anything to work. Hopefully, we're getting real close. Fingers crossed. So what robot chassis have you got on the printer that isn't actually isn't getting worked on tonight? What is it? Because I think, yeah, I'm pretty sure I know both of what Razor and Tom are working on at the moment. I've seen both of those, but I don't think I know. I designed pauser industry to have a regular brushed drive motor to power the shuffling drive, but that was not nearly enough, so I ended up using 360 modded servos. Oh yeah, fair enough. That's I mean, yeah, 360 servos can be okay. They can be a little slow, though, I find, especially in the Antweight division. Every time I see somebody use 360 servos, especially for a first Antweight, I'm like, oh, I wish you'd looked around a little bit further online, like seen what other people are using, like gone to an event first, because I feel like you get out-competed with them, but I feel like up in beta weights, you can make them work, and obviously you have with your own robot. But yeah, down in the Antweight class, people should not be using modified servos. They're just too slow, effectively. You can use the ESC out of a servo, or especially out of a modified servo, but yeah, stick it on an N20 and get yourself a good 30 to 1 or 50 to 1 or something, and, you know, do it properly. Or, not properly. Want to say properly? Yeah, I'm going to say properly. Because it's one of those things that they're not that expensive and everybody else is running them, so you might as well be, basically. It's a vert with lifter arms, kind of like Big Deal or Terratops. Nice! Yeah, I haven't actually done a robot like that has a control mech and a weapon on it. I would like to at some point. They look like a lot of fun, but they also do kind of feel like you need a lot of hand-eye coordination and attention to drive something like that. They feel like they're going to be an interesting beast to fight with. The overhead saw that I run is, or have run in the past, is kind of similar. You have to have some level of some extra level of attention given to the robot. Although having said that, I did cheat that a little bit by putting the saw speed on a 3-position switch, so it had off, mid, and high, and then I was literally just like set and forget on the saw speed, and then was positioning the arm as needed. But yeah, I feel like a vert with lifting forks is a bit of a different ball game than that type of thing. Because, yeah, I don't know, I'd still kind of want a vert on a stick, I think, rather than on a switch, because I like having full proportional control over a vert. But then again, that might just be me. I know that a lot of people don't do that and just run all their weapons on switches because, you know, you want the weapon to be at 100% or 0%, but especially for a vert, driving gets a little bit difficult if you can't control the speed of the vert as you're driving around, and, you know, getting control over your gyro forces can be a big improvement. I really need to find shorter screws than this, because these screws were for the spacer block and they don't need to be this long, effectively. They really are quite long. I think I mean continuous servos, not 360 servos. Oh, yeah. That is right. That is my bad. I sometimes forget that those are different things, because I'm so used to servos being like 180-degree servos, and just forget that you can get servos that do 360-degree positioning. Yeah, because actually I don't know how they work internally because potentiometers usually aren't a full 360 degrees of angle on them. They always have a little bit of a dead band in them somewhere, so they must be using encoders or something. That'd be interesting. I should buy one and pull one apart at some point and see exactly how a 360 servo works. And yes, you were very right. I was thinking continuous. I was not thinking 360. All right, let's see if I've got shorter bolts. These look like shorter bolts. Ah, they should do the job. More than likely. Oh yeah, look at that. And the holes in this are a little bit better. I'm a bad driver, so most of you be a fork vert. Yeah, fair enough. I mean, I feel like that's what would happen if I did something similar. There's another bolt. It looks about the same size, and it is awesome. That is what I wanted to see. Let's get our spacer back in here. This spacer, by the way, literally is just a piece of very badly drilled 3mm MDF, and it is only there because there are welds in here, which the 3D print didn't accommodate for, and so rather than reprinting these, I literally just cut a plate that spaced it off a little bit and meant that the print didn't have to interact with the welds or where the welds were, because I did grind them down a little bit. Right, now I want the smaller of the two belts, which is that one. Boop. I need to put nuts back on here. And if this is close, I can then overnight or tomorrow print a new version of this that is slightly bigger sized. In fact, we could sit down and we could work out that together. I would need to, yeah. I'd need to get the stream sorted out so that you could see OpenSCAD, but that would be a thing that we could absolutely do. All right, that is on there well enough. Good enough for jazz and testing. Not good enough for full competition because it needs lock nuts on it for full competition. But there we go. All right, that's in place. You there. Ah! Sorry about that. I just booted the microphone again and dropped something else. What did I drop this time? Oh, a spacer that I used very, very early, like way earlier in the day. So I don't really mind too much about that. All right. So again, we're going to line all this stuff up. Right, okay. So this is definitely too small. This hits the third of the 3 sets of holes in here, which I'm not sure if I can show you that all that well or not. I want it to sit about here, but that is a lot of slack, like way, way too much slack. So, yes, we need a bigger pulley, but not as big as the other pulley. I do need to work out how big this pulley is, though. You had to remove the potentiometer to get them run continuously. They do get really hot when you run them much longer than the 3 minutes. Yeah. So that is a continuous rotation conversion. That's how you do that, is you remove the potentiometer and usually solder a set level of resistor across where the potentiometer was, and then it will run like that. I'm not surprised that they got hot. Those ESCs usually don't have like good current limiting on them or even a good current ratio, current rating on them. So yeah, they will get quite warm if you let them. And I've had that happen before. Once, a while back, right before I was getting into combat robots, I had one of the little 9-gram servos on a 3D printed mount, and if I got it to lift something and keep it in a position, it got really hot. Hot to the point that the print around it started to get a bit soft. So I had to, use something different for that. Actually, I don't know. I may have even abandoned that project. Yeah. these things happen. Um, but yeah, like I said, they can get quite warm because they're dropping a lot of current through, and they're not really rated for it, so they're wasting a lot as heat, which is not great. All right, where are we at now? Then we are here in a big mess. So I don't have, as I think I've mentioned a couple of times on stream so far, I was meaning to have the motor mounts ready to go so that we could mount these motors in, get that all ready to go, get that rocking and rolling, and have that system in by the end of the stream. Unfortunately, yeah, with the weapon not working, that didn't happen. So we are here instead. And also, I didn't have wheels for it. I've got reach some new wheels made up already. These are a urethane rubber around the edge and should work quite well. But yeah, the robot's not ready for them. They are ready for the robot. The robot's not ready for them. Although I've only got 2 of them so far. I've got the other 2 in the molds right now because the molds take like 10 hours to print a piece. So I've been not printing a lot of those. Although I do have a full set now. It's just that, yeah, I made the first 2, made the wheels, made another batch of wheels, then printed more. So I'll probably make a spare set of wheels to take with me to Brisbane because you're going to burn through some wheels, I think. Right, I was going to... Did you ever pick up the new Malinkis or the high voltage Malinkis? I had to because a bad ESC killed one. I haven't yet. I've been meaning to. I use the Malinkis fairly regularly, and the new ones do look very interesting to me, especially the new form factor in them looks really interesting to me. So I want to do that, but I haven't yet, effectively. All right, what I'm going to do is I'm going to pause for half a second here. I'm just going to throw up the streaming soon screen, and I'm going to move some stuff around because I'm going to start work on a new pulley for this thing between the 2 ranges here, and I'm going to take you with me on that. And then that's probably going to be the last thing we do on stream, but it's going to be a little while to kind of get a new pulley again in between the 2 of these here. But like I said, half a second, I'm going to get OpenSCAD up and I'm going to have OpenSCAD come up on the screen, but I need to move the webcam from here to over there so I'm looking at you and my computer at the same time and not this kind of weird situation we're in right now. Half a second. Okay, we should be back now. So this is OpenSCAD. This is an open CAD software. It's effectively software CAD because you can see down the side here, we actually have a CAD window, or we have a coding window up. I'm going to grab chat actually because I was not looking at chat. He's gone. The world is going to end. Yes, no. We're all good still. We're here. But yeah, so this here is OpenSCAD. I use it because it's really good for things that used to work with Tinkercad's customizer. A lot of them were written in OpenSCAD, and how the customizer worked is it literally just used these things over on the side here, and you changed those with a UI, and it was really nice. But unfortunately, that doesn't really exist anymore. Thingiverse is so broken that their customizer doesn't really work anymore. So we need to use something different, and that something different is this here. So I also need to very, very quickly look at some stuff that you can't see because it's all in my back-end code, back-end file structuring, because I need to try and work out I need to work out how big the old pulleys were. I mean, the other way we could do this is we could do it by measuring things. Wild, right? Who would measure things to do CAD? Okay, I did not label any of my pulleys. Well, that's great, isn't it? Okay, so in my file structure, normally, especially nowadays, I will label things so that I know how many teeth are on a pulley, for example. But it seems like in the old version of Strange Young Man, when I did this CAD, I literally just called things lifter pulley and not a number of teeth on that. So that's not great. But I can work this out pretty easily. I'm so bad at designing gears in Fusion, I really need to spend time watching videos and goofing around with it. I can show you some gear design as well if you'd like. That shouldn't actually be too hard to do here. I will show you that in a little bit, because what we'll do this, we'll do the thing I want to do, and then I can show you gears in Fusion, because I've done a number of gears in Fusion. There's a cool little like generator-y thing that you can use. Alright, so what we're going to do, I'm going to cheat this. Oh, did my camera just like refuse to focus on me? Anyway, we're going to cheat this a little bit. I'm going to go back to the desk, and then we're going to zoom down. And I'm not going to forget to put that back again. But what we're going to do, we're going to measure this. And the measurement of that is saying about about 77, which is backwards for you. But 77 millimeters. So if we now go back to OpenSCAD, what we can do here is we can, as mentioned, cheat this a little bit. So what I'm going to do is I'm going to take this motor shaft feature and I'm going to set that to 77 millimeters. So what that's going to do is it's going to bore a hole through our pulley that is 77 millimeters. Also, my camera is not focusing. We're going to fix that. Right now, give me half a second to get that fixed. There we go. Okay, that should stop doing the weird blurry thing that it was doing. Yes. Gear generators are really, really good. And you're right, as long as you know what you need, they do the work for you, which is cool. Hello. In chat there. Right, so, as mentioned, we've measured the pulley. It is 77 millimeters, so I've put the motor shaft to be 77 millimeters. I mean, I could also do this by using the pulley retainer, because this system does have a pulley retainer in it as well. And then I'm going to set the number of teeth to be really high. I'm going to say 80 here. And then I'm going to generate this. And you can see that's our 77 millimeter hole, and this is 80 teeth. And so we've got way more teeth, because if we had exactly the number of teeth that this pulley has, it would be gone. It would have disappeared. So we're going to drop that down. We're going to do 70 now. And then we're just going to bring this back in effectively until the pulley disappears. But once we get close, it might even be 50. Okay, it's not 50. It's just above 50. Sorry, just below 50. Like if I do 48, I would expect disappeared. Cool. If I do 49, is it still gone? Yes. All right, so it's probably a 49 tooth pulley. It could also be a 50 tooth pulley and it'd be an issue in my measurement. So let's assume it's a 50 tooth pulley for now. Our motor shaft diameter, this is actually the thing that we want here, is the diameter of the pipe that we're using, which is 22 mil. So let's put that to 22, but we're going to do 22.3, give it a little bit of clearance. So that is a 50 tooth pulley. OpenSCAD is a little bit interesting in the way that the mouse controls work, so I often or sometimes forget exactly what all of those do. I'm just going to double check that this is a 40 tooth pulley on the other side, because that means we need something between the 40 tooth and the 50 tooth. So I'm probably going to go, I don't know, 46 or so, somewhere up kind of high, because there was a lot of give in the 40 tooth pulley and we were real close on the 50 tooth pulley. So in actual fact, a 48 might work as well here. So we can actually do that. Let's do a 48 tooth pulley. Whoops, don't want to hit enter. I want to re-render. So that's this button up the top here where my mouse is. That is the re-render button. To get an STL out of this, I would have expected that to turn into a ring gear with the teeth on the inside. Yeah, no, there's a whole different generator for making ring gears. So effectively, like what this is doing is, if we look way, way down here at all of this weirdness, what this is doing is it's generating the actual shape by creating basic geometry, so like squares and circles and yada yada yada. It's creating those basic geometries and then extruding them around things and cutting holes through them. So the hole that is being made will be one of the last steps that the thing is doing. Like if you think about this down the side here as a like auto-generated Fusion 360 timeline, one of the last things that happens in the timeline is that the hole gets plunged through the middle of it. So anything that's in the way of the hole just gets eliminated as it goes through, which is why if your teeth size is underneath your motor shaft radius, the whole thing just vanishes, because it all gets eliminated by that massive extrude at the very end. Yeah. What am I printing them out of? That is a great question. The ones that I've been playing with today, the big ones, like the white ones, these boys, these are printed out of TPU, basically solid out of TPU. The green ones and the other smaller ones that went on the lift motor are out of PLA, and they survived screws stripping, like 6 M6 bolts stripped before the teeth sheared off these PLA prints. So I'm kind of blown away by that, to be perfectly honest. Yes, so we now have a pulley though. So we have a 48mm pulley. The thing that this can't do is it can't punch holes in this. So I'm going to need to take this off to something else to punch holes in it. I personally like to use Tinkercad to punch holes in something like this, because Tinkercad is a really, really good mesh editing software. It just handles like STL meshes really nicely. So I would do that. But to do that, first of all, we need to render this. So we actually now create the full model. So what we were doing was we were previewing it before, and now we're rendering it. And you can see down here, it takes a little bit of time to render this actually out and get it working, and working out where all the polygons go and stuff. And once that happens, we can then export that, and that will then, it gives us a nice little bidding sound. And then we can save the STL out, which I have another window up that you can't see currently, which is probably good because it is just in my file system. So I am actually... what I'm probably going to do here, to be honest, so this will save into the same spot that I put all my Strange Young Man stuff. I'm going to call this a HTD5 48 tooth pulley, so that I know next time what actual size pulley this is. But I think what I'm going to do as well is I'm going to make... So I've made the 48 tooth, but just in case that's still too big, what I might do is I'll make a 46 as well. So I'm just going to go through exactly the same steps here. Render stuff out, get it all rendering, and then we will export that as well, save it as a 46 tooth pulley, and that'll be that done, which would be good. I'm keen to have this working. And yeah, like I said, I'll punch holes in them in Tinkercad and probably print them overnight, and then I will try them out tomorrow morning and hope that they work. Yeah. Getting these pulley sizes perfectly dead on is going to be critical, because if the belt isn't tensioned enough, it is just going to skip, which is what I've already seen out of this. Oh, we've got that, so we can save out an STL. 46 tooth pulley, we'll just save that at the same thing. I know you guys can't see that, but that's fine. There we go. Okay, so if I do this, I'm going to bring up Fusion 360. And we are going to have a very quick look at the Fusion 360 generator for gears, because that's a fun thing to do. All right, you're going to have to give me half a second here as Fusion loads and as I set up OBS to work. Actually, I can go into that mode, and then I can set this up without making the changes be real weird on your end of things. We want that, we want that, we want that, and that's not worked. Okay. Sorry, half a second. Trying to modify OBS Live is an interesting thing to try and do. No. Let's edit this. Sorry, half a second. We're almost there. I'm just getting Fusion. Okay, here we go. So this should be, you should be seeing Fusion 360 right now. This is a blank workspace in Fusion, fairly obviously. Usually what I do before I get to this point is I'll have mocked up where I want my gears to go. So I'll have mocked up where my motor is and where the output of the gear system is, and know the kind of distances that I need, and then also know my gearing ratio as well. I don't have any of that this time because we're just kind of going to wing this a little bit, but we are going to go into utilities. Yes, content, A+ content of me futzing around with OBS, trying to get Fusion to work with OBS. Great content. But yeah, so gears, going into utilities, going into add-ons, going into scripts and add-ons. And then inside the my scripts here, we have spur gear. Now I choose the Python version and then we hit run on that and then we get this spur gear generator set up over in the corner, which I'm going to move out here for a little bit. So first of all, metric or English, imperial, that would be gears. Obviously I'm an Aussie, I use metric gears for everything because that is just the easiest way to do things. Then I look at module. So module is how big the teeth are from memory and number of teeth. And then you look at, so there's the other thing of hole diameter and pitch diameter. So pitch diameter has got a handy little thing up the top here that shows you what pitch diameter is. Pitch diameter is half the depth of the tooth. And so for two gears to mesh nicely, or at least for me, the way I work this is if I've got a distance between centers that I need my gears to be of, say, 40 millimeters, then my two pitch diameters, I get my pitch radii off of those, and it needs to be 40 millimeters. Basically so that the pitch diameters just touch each other when you actually move the two parts apart. Module, I usually go down quite heavily because I'm usually putting in quite small gears, especially for ant weights. We're going to do 24 teeth, and here we go. I'm going to try and hit a pitch diameter of 40 mil exactly. So we'll do a 1-to-1 gearing set that will sit 40 mil apart from each other. So we've got a module 2. So I can now, I've got two options here. I can either drop my modulus to try and drop pitch diameter, or I can drop my number of teeth to try and drop pitch diameter. In this case, I think I'm going to go down in module. So here we go, we've gone to 36. So let's go up 1.8. That's too large. 1.6, 1.7. Okay, 1.7. So 40.8 millimeters pitch diameter here with 24 teeth. I usually leave that alone. Root fillet radius is the kind of radius at the bottom of the tooth here, and I just set it to whatever Fusion tells me to set it to. In this case, it needs to be less than 1.00, so we're just going to go 1, and that'll be totally fine. Gear thickness, it pulls this weird imperial thing in. I'm just going to set that to 5 mil, and then we're going to put a hole in the middle of, actually, what is an N20? 3? I think 3 mil? We're just going to throw 3 mil in, just for the sake of that. And then we're going to hit OK. And then this is going to generate 1 gear. So this gear should, if I go into the measure tool and measure this, you should see that the radius is 20.4 and the diameter is 40.8. So I should also just check, you guys are saying Ben.exe has stopped responding. Is the stream still working, or is that just in reference to me trying to get Fusion working here? Oh, cool, yes, N20 is 3 millimeters. Great, I'm glad that I got that. So yeah, here we go. That is a diameter of 3, and we've got this with our pitch diameter of 40.8, radius of 20.4. So then I can copy this, and the reason I'm going to do this is to show you, so I don't want to move, how do I do this again? I've forgotten how to copy full components in Fusion. It's been a while. Oh, here we go. Okay, so we're going to offset the X distance by 40 and hit OK. Just me running Fusion. Yeah. So here you can see, if you look at this pitch diameter, you can see that these pitch diameters just overlap each other. And this is actually probably not great. You probably want them to be closer to touching than this, especially for these size gears. Although if I move this, let's throw this back over on the side here and kind of... yeah, okay. So here we go. I've definitely messed up my pitch diameter here. You can see that even at, we throw this to like 6, or 7 or 8. Yeah, you can see that my gear mesh here is bad. Like, these teeth do not line up at all. The gear meshing is quite horrid. So I actually need to redo these gears entirely if I want them to be 40 millimeters apart, which is what I said I wanted them to be. So it turns out that for gears this size, a pitch diameter of 40.8 is kind of bad. And hello in chat there. Good to see we're still getting some people coming through, despite it being quite late. Well, it's now quite late here in Australia, but of course, I know that there's some of you who it will be like mid-afternoon or early evening or early morning, maybe even. So anyway, yes, our gears here are wrong, so let's redo them. The good thing about Fusion and this particular add-in is I can just go back in here and open this up again, and it should still have, so my module is still 1.7, everything is still the same as it was, but we now know that's not right. So I'm going to, actually we can keep 1.7 and maybe just drop the number of teeth. Let's try, okay, so 23 teeth is not right. You can see we've gone way too far down here. So let's go back, actually let's go to 22 teeth and up the module a lot. See how we go. 1.9. It is morning time here still. Right, okay, yes. Time zones do be like that. Okay, so now here's the thing with setting around, like messing around with this module a little bit. As far as I know, modules are like a set thing. There are set modules that you'll be able to buy for gears. If you're doing this to print gears, like I do, you can mess around with your module as much as you like, and it doesn't matter. You can just print whatever gears you want or need. If they need to mesh with pre-bought gears, you may have to find specific teeth sizings and things. Yeah. Pitch diameter is module times teeth. Right, yeah, okay. Yeah, so that makes sense. Right, so that means then if I do this, number of teeth is 20 to 40 pitch diameter. Yeah, okay, cool. It's late for me, even though it's morning. I'm trying to switch my body to working overnights. Oh, yeah. Overnight shifts can be quite rough, especially when you're not used to it, or when you're swapping back and forth all the time between overnights and day shift. That gets quite rough. Okay, so now we've got a pitch diameter of exactly 40. So let's copy this guy again. And move it again, 40. And now we'll see that our pitch diameters just touch each other here. And then if we grab our second guy and do the move thing again, and this time get the right point, I want probably about 0.9. You'll see that these gears basically just mesh here. So that's personally how I do this. I will butts around with my module and my number of teeth until I get pitch diameters that work. And I mean, when I'm trying to do a ratio and not a 1-to-1, it does get a little bit harder because you have to do effectively 2 lots of this where you're like, you set a module and then try and find number of teeth that work to get pitch diameters to work for your exact spacing. I mean, I guess the other thing too is you could just go into this with a set gear ratio in mind, build out some gears that you want, find the modules of those, use that to find the distance between centers, and then use that in the rest of your build process. It is, definitely a way that you could do it. It does look tight, yes. And you're right, it is a little bit tight, but those gears would work. And I have done that type of thing before, exactly. And the other thing too is that, this is a 3mm hole, this is a 3mm hole. The thing that it's sitting on is probably not going to be exactly 3mm, especially if you run a bolt for one of them. So there is going to be a little bit more slop in them than there is in CAD here. So yeah, an exact fit is not the worst idea. And also, if you really are worried about this and you want a bit more clearance in here, there is that setting. If we go back into here and go back into the spur gear and run it, there is this backlash number in here that you can change, which from memory is the thing that will like reduce your teeth off a little bit, so you get a little bit more play in those teeth effectively. Cool. All right, I think I'm kind of out of things for this evening, I think. Yes, I have done the OpenSCAD stuff. We've had a look at Strange Young Man. I've kind of explained a little bit what we're doing with that. I definitely need new parts, though. I don't think I ever mentioned, though, what was the second option here. So let me just really quickly, let's go back to the other camera, and we will have a look at that. I'm just going to have to, oops, that's not what I wanted to do. I'm going to have to throw you guys back on the streaming soon sign so that I can move some stuff around again, and then we will be back to the desk. Oh, right. Sorry. That should be better. Can you hear me now? I'm just going to make sure you can before I move on. Also, because of course you're over here and I was looking this way. I was not seeing you say no sound. So, right. Please tell me when there's sound. Hopefully that has fixed the problem. Oh no, we've gone deaf. I sure hope not. I hope that my microphone is still working. Oh, cool. Okay. Cool. So what I was saying while I was fully muted there was, yeah, no worries on the quick tutorial there. I'm not an expert on Fusion 360. That's why I don't really do too many tutorials on it on my channel. That stuff that I showed you is all I ever do when I make gears myself. I'm sure there are other people who can come along and tell you a lot more about making gears on Fusion 360. It's definitely worth looking up other tutorials on it. But like I said, the stuff that I showed you there is all that I've ever used personally. So, you know, your mileage may vary, but that works for me. So we're going to now actually look at Strange Young Man again real quick. So rather than using the big motor here, which we can use, I can totally use this if I want to, or I have the other option, and that other option is these. So these are exactly the same gearbox as the drive, just bigger. So the drive are 16:1 gearboxes, these are 100:1 gearboxes, but they will also take a 28mm motor. So my thinking on this was to put on, and I had some 28mm motors, yes, here we are. So I've got some other 28mm motors, which I don't know exactly what size, what speed these are, but I think they're over 2000 kV. So mounting these into a 100:1 gearbox and then this to the axle, like so, with kind of a 3:1 or a 4:1 or something along those lines, and doing two of them. So basically doubling these up, which would effectively look like, so this on the back of that, and that sitting way down here, and then a whole other one sitting here with the second motor. Yes, I can grab it. Second motor here, and then both of those belt driving the axle. This is much more labor intensive though, because I would need to, cut these shafts down a little bit, press fit on new gears, run them into these, work out new pulley ratios for this system, print off other pulleys, one for the front and one for the back, and just get everything working. But it would be possible theoretically. The problem with this is that this is definitely a case of spend 24 hours or more working on it, and there is more than half a chance that at the end of all of that work and effort, there's not enough torque in there to lift even the hammer extension. It would be fast, though. That is the big thing here. It would be very, very fast, probably, because, again, these, I got them off AliExpress. The seller did not list any real specs for them. Searching the name on them, which is eSky, if I can like tamp that down a little bit. I'm not sure if you can really see that on there, but they're called eSky motors. Searching those, I found a blog post about them where somebody claimed that they were 3200 kV, which is ridiculous. But that threw that gearbox down by 300 to 1 effectively. Should still be really fast and still have enough torque to move things around, but again, it would be a case of 24 hours of building before something even comes together on the robot, and it could fail and fall over. Hence, moving to the Chunky Boy motor, wherever I put that, I put it down. Oh, here we go. To the Chunky Boy motor, because most of the parts for this are already working and together, and I can just throw this at the robot and see if things work. And as we've seen, close enough. I just need a new pulley here and maybe it will work. So hopefully we can get that all together. Yeah, right. I think we're going to end the stream there before I get any ideas and put up the Strange Young Man gaming thing that I had for April Fool's Day. But yeah, that's where I'm at with Strange Young Man at the moment. And yeah, again, there should be a video about him out on Saturday while I'm over in Brisbane fighting him, hopefully with something working. One of these two systems, preferably sooner rather than later, because yeah, we're getting real close to the wire here on this one. Yeah. It's been a mess. This system not working has been just a real pain. A massive pain. Anyway, thank you all for being here and watching through the stream and chatting to me about what it is you're doing and all that kind of stuff. It's good. I enjoy this type of thing. I need to do some more streams. But yeah, it can be a little bit difficult to sort things out and stream in a way that I'm like not giving too much away for spoilers for future videos, but also like showing you interesting things that I'm working on and doing. And yeah, I thought this was going to be a build Strange Young Man stream, and then as it slowly morphed into not, I was like, you know what? I can just show you my thought processes and the things that I'm going through and trying out and working on, and you know, what happens when I hit problems in a design a week out from an event. And it is mad scramble to try and find literally anything else in my collection of random robot parts to make work and make do a thing so that I can at least get, 3 minutes in the ring, maybe. Anyway, thank you all, and yeah, I will see you in a future video.